All right, so we're going to call this dividing or multiplying rational numbers. And so, like we said before, rational numbers are just basically numbers that can be written as fractions. They're numbers that can be written as fractions. So basically, if I have fractions and I multiply them, I'm multiplying rational numbers. Okay? So basically, we're going to multiply some rational numbers. So I want to just see kind of what you remember. Suppose I have 1/3, and I'm going to use the dot for multiplication. And I'm going to multiply that by the number 9/4. So write that down. 1/3 times 9/4. Have you done this before?
Yes.
I want to see what you remember about this. So if I'm multiplying, what's the procedure that you've learned? Yes. Okay. We're going to save that for adding and subtracting. When we add and subtract, we are going to want the same or common denominators. That's why I asked, because, it's been a while, kind of the rules get kind of jumbled. So we don't have to worry, thank goodness, about common denominators. There is one thing we should do, otherwise it causes us a lot of work in the end. Yes. Actually, that's okay. We actually want them as improper fractions. But I'm trying to see if you remember them. I don't even know if they even call it this. Yes.
You multiply 1 by 9 and make 9, and then you put a line over it, and you put 3 times 4 and make 12, which is 9 times 12, and then you simplify the 3.
Yes. So one method, this is one method, you just multiply across. Multiply numerators together, multiply denominators together. That's one method. We'll go over maybe the other one, and then I'm going to ask. Yes. That's called cross canceling. So method one is just multiply. I'm going to write it here. Multiply across. Okay? So we're just going to multiply across. And so let's do that. We're going to multiply 1 times 9. That's 9. And we're going to multiply 3 times 4. That's 12. But we always should simplify, right? In this case, what divides out of 9 and 12? 3 divides out, so we'll be left with 3 and 4. And that's our actual final answer. 9 divided by 3 is 3. 12 divided by 3 is 4. We end up with 3/4. Okay? So, that's one method. The second method, method 2, okay. So Sarai, I'm going to write the same problem down and maybe you can help me. Okay. So were you going to give me a suggestion? Yeah. Did you learn about cross canceling? Okay, that would work. And what that does is we don't have to do this uh, simplifying at the end with bigger numbers. You usually simplify with smaller numbers. So what you do is, I kind of call it the butterfly. You look at the numbers that are across from each other, and you see if there's anything in the numbers across from each other that you could simplify. So between 1 and 4, can I simplify anything between 1 and 4? No. How about between 3 and 9? Yeah. 3 goes into 3, 3 goes into 9. So this is the cross canceling part. You take 3 and divide it by that common factor 3, which 3 divided by 3 is 1. Do the same thing with 9. Divide 9 by that common factor 3, you get 3. So now you got smaller numbers and you multiply across with those. So we get 3/4, which is the same answer, which we should get. They each have their advantages. So in the second method, we cross cancel, then multiply. And it's really up to you which one you prefer. Both are fine, both work well, both are going to serve us what we want to do. But as a class, which one would you rather do? Because I can't do two. Method 1 or method 2? Give me a finger. Or 2. One if you like method 1, would be method 1. Method 2 if you like. Okay. I'm seeing more ones than 2, so we'll do method 1. Okay. But if you're a cross-canceling genius, that's fine. Let me warn you though, those method 1 lovers. We're going to have a few examples today in the notes and in the assignment with variables. This is really going to be easier. Method 2 is going to be easier when we have variables. So it's up to you. On those, I am going to do method 2. Okay? So here we go. Let's go ahead and I'm going to throw in some, we're going to do some examples. We're going to find the product. Find the product. Write in simplest form. So I'm just going to say in simplest form. Okay. So go ahead and write that down. And we'll just do a few, kind of a little combo of all the possibilities we're going to have. Okay. So you guys ready? So we're going to do number 1, negative 2/5 times 7/6. Again, we have an improper fraction for our second, the second value that we're multiplying. That's okay, leave it that way. In fact, when it is a mixed number, we're going to want to change it into an improper fraction. Okay, so we're using method 1, right? So it's important to see here what kind of result are we going to get? A positive result or a negative result? Negative. So that's all you got to worry about. When you see the numbers you're multiplying, decide, okay, is that going to be a positive answer or a negative answer? And you'll know right away. I know it's going to be negative. Okay? Now, I'm going to go ahead and multiply 2 times 7. That's 14. 5 times 6 is 30. Now, we have to ask ourselves, 14 and 30. There is a common factor. What's the number 2? So we're going to divide each number by 2, and that would give us our final answer, which is negative 7 over 15. Okay, negative 7/15. And that is our answer. Any questions? Okay. All right. Let's try this one. Number 2. Negative 3/11 times negative 44. I'm going to try to persuade some of you that not a big fan of that cross canceling to maybe go into the dark side. Yeah. If you're multiplying times a whole number, we got to change it into a fraction. Remember how you make it into a fraction? 1 is the denominator. So we're really multiplying negative 3/11 times negative 44 ones. So first the easy part. Answer, positive or negative? Positive. Okay. So that's all we got to worry about with the sign. Now, here's the catch. We're going to have to multiply 3 times 44 and then 11 times 1. And then we're still going to have to reduce. I'm telling you now. So this is where it's actually easier to cross cancel. Look at your numbers across from each other, okay? So look at those numbers that are across from each other. 3 and 1. Can I simplify anything between 3 and 1? 11 and 44. Is there anything I can divide out of 11 and 44? 11, right? This is where it gets easier if you cross cancel, because divide 11 by 11, it becomes 1. So I'm going to cross it out and just put a 1 there. Divide 44 by 11, you get 4. So basically we divided by 11. And now look at how easy this answer becomes. We're going to go ahead and multiply. We know it's positive because it's a negative times a negative. 3 times 4 is 12. 1 times 1 is 1. 12 ones is actually 12. So you end up with just 12. Okay? Any questions? Okay. So I think it's time to throw in maybe some mixed numbers in the mix. Number 3. Okay. Let's do negative 5 1/2. And we're going to multiply that times 2/11. So write that down. Negative 5 1/2 times 2/11. First thing we have to do is rewrite this problem. Negative, yeah, hold on. I'm just giving everyone some guidance here. If you get a mixed number, you want to change it to an improper. Okay? Change it to improper. So let's do that. So, Gabriel, what was this if you change it? Negative 11 halves times 2/11. Okay? So, negative 11 halves times 2 11ths. Oh, I so want to cross cancel on this one. Do you see why?
Yep.
All kinds of stuff cross cancels. Shall we do it? Do you guys are the method 1 people okay with that? Otherwise, I'm going to have 22 over 22 and I'm still going to get the same thing. And it's just so satisfying to cross cancel. I don't know about you, but I like it. Okay, here I go. Cross canceling. First of all, positive or negative? Negative, right? Negative. I'm still multiplying a negative times a positive, so it's a negative. And then let's see what I get. I'm going to cross cancel. What can I divide out from across here? Between the 2 and the 2, what divides? 2. So between these, 2's cancel. 2 divided by 2 is 1. And that happens on both. Between 11 and 11, what cross cancels? 11. So I'm basically left with negative 1 over 1, which is just, what's negative 1 over 1? Negative 1. Okay? So, and you know what? I got to admit something right now. It happens every year that more students are in favor of method 1 than method 2, and I kind of pick these problems to kind of coerce you into trying the cross-canceling method, because you'll see once we get into a few variable ones in a little bit that it's going to be better that way. Okay? Let's try this one. Number 4, negative 3 times negative 8/9. Okay? Negative 3 times negative 8/9. Give it a try. Try it on your own. See what you get. And see if it matches my answer. Negative 3 times negative 8/9. Now, how many of you ended up with an improper fraction? Okay. How many of you changed that improper fraction to a mixed number? A few of you, okay. So this is what I got, 8/3, right? So real quick, I put 3 over 1, and then I did the cross canceling because I noticed 3 and 9, you can cross cancel. Now, if you did 24/9, and then simplified, that's fine. But this kind of gets rid of that. So I got 8/3, and that's fine. If your final answer on today's assignment is 8/3, I'm perfectly okay with that. Or if you decided to change it, let's see, 3 goes into 8 how many times?
2.
And 2's left over. If you wrote 2 2/3, that's okay too. Your choice, okay? All right. Any questions? Yes. The cross cancel? Oh, yeah, you could multiply across. Like I said, if you ended up with 24/9 and then reduced it to 8/3, that's fine as well. Okay? All right. Um, I think. Well, I want to do one more, just because I gotta. So this will be the last one here, and then we'll do some with variables. 8 and 4/5 times 2 and 5/10. Yeah, that's the one. Let's try that. So 8 and 4/5 times 2 and 5/10. Help me out, please. What's the first thing I have to do? I got to do this. Yes. Actually, even before that. Yeah. Convert to improper. Yeah, otherwise, it's a lot messier. Okay. So let's see. 5 times 8 is 40. And 40 plus 4 is 44 fifths. Times, we get 20, and plus 5 is 25 tenths. Okay. Now, hold on a second. If you want to do method 1, look at what you got to multiply though. 44 times 25. That's pretty bad. And then 5 times 10, that's 50. That's easier. But then you still got to reduce after that. Yes.
Couldn't you just simplify to 2 and 1/2, and then you put it.
Oh, okay. Yeah, but I wanted to scare the people with it. You're stealing my thunder here. But yeah, definitely. Because I still want to practice cross canceling. I'm kind of inching towards the what we're going to do next. Okay, so let's divide out between 5 and 25. What can I cross cancel? So 5 goes into 5 once. 5 goes into 25 5 times. How about between 44 and 10? Let's try 2. You can always try it and then see if something else works. So I think 2 is going to be it though. So if I divide 44 by 2, 22. If I divide 5, and let's see. And so 22 times 5 is what, 110? Divided by 5. Guess what? We still have to do one last thing. Yes. Divided by, well, does 5 go into, does 2 go into 5? Yes. Yeah. And that's kind of the reason I I was hoping in every class at least 1 or 2 students catch that I could have reduced this at the beginning. Okay? And it's kind of a little lesson to, if you can, reduce it. But since we didn't, at the end, still got to do a little reduction. And that'll happen. So I know that I can divide 5 into 5 and 5 into 110. And then I end up with, what is that, 22 over, which in the end is 22. Okay? So real quick, what did we learn here? That the positives and negatives behave the way they did before. If you have mixed numbers, you have to, what do we have to do with the mixed numbers? Turn them into improper. And again, you could use the first method where you multiply first, then reduce later, or you could do method 2, which we call cross canceling, which is reducing along the way as you go. Okay. So let's use all of that when we have variables. So we're going to do a few examples here where we're going to have variables. It's still the same idea. So we're going to be using variables. And variables are letters, right? But the letters behave as numbers. So here's the first one. 6a, that means 6 times a, over 5b as in boy, times 10b over 21a. So all you have to remember is, yes, we have a's and b's in there, but they're behaving as numbers. So I have 6 times a and 5 times b, 10 times b, and 21 times a. Okay? They're all just factors. They're factors. Okay? So, and what we can do is we can look across from them, each other, and if you have a common factor, it cancels. So let me just show you with the first one. I have a here, and down at the bottom here, across from it, I have a. They're common factors. One in the numerator, one in the denominator. So they cancel out, they divide out. I can do that. What else can I cancel out? Yeah. Well, let's just stick with the b's first, and then we'll move on to the numbers, because I want to clean up the variables first, if I can. And I can, right? I can cancel out this b with this b. If you have one in the numerator and one in the denominator, even if they're across from each other, they cancel. So all of those canceled out. Now let's go on to numbers. Really, I have 6/5 times 10 21s. Can I do some cross canceling with those? Yeah. 5 divides with 5, and I get 1. 5 divides with 10, and I get 2. I got that. And then I can cross cancel 6 and 21, because what goes into 6 and 21? 3, right? 3 goes into 6 2 times. 3 goes into 21 7 times. So I got all of this, but I canceled out variables. They're gone. Let's see what I got left. I got 2 times 2. I still have 2 times 2. I got 1 times 7, so that's 7. So in the end, after everything cancels, I get 4 7. Any questions on that? Okay. We'll do a few more. So everyone's okay with that? Didn't go too fast? Okay. Let's try this one. 5x over 17 times 2 over xy. Okay. So go ahead and take a look here. I like to start with the variables if I can, and cancel anything that's the same on the top and bottom. So what can I cancel in variables? X, yeah, this x. By the way, if you're wondering, what's xy mean? You're multiplying whatever x is times whatever y is. So it's just multiplying. So they're not like connected where you can't cancel one out with the other. It's all just multiplying. So this x cancels with the x on the denominator. So let's do that. This this x cancels with this x in the denominator. And I can't cancel y's, can I? No. So it stays. Now let's look at our numbers. Look at 17 and 2. Can I cancel anything between 17 and 2? Is there a common factor? Nope. So now we just multiply. So now we're just going to multiply. Multiply 5 times 2. Multiply 17 times y. Does anyone know what that is? 17y. And that's your answer, 10 over 17y. Okay? And that's going to be an answer. Later on, if we have equations and we know what y equals, then we would go ahead and work that out. Okay? All right, we got a couple more. This one will have a lot of variables. Oh, yeah. Number 3. GH, that means G times H, over 9I times 18I over G to the second power. Okay, so now we have more variables than numbers. Okay. So is there anything we can cross cancel? The G's and the I's. Let's start with the I's because those are pretty simple. I have one I here, I have one I there. And they're in. One's in the numerator, one's in the denominator. So these are easy to cancel. This I cancels with this I. I have one here in the bottom, one on the top. They both cancel. Now let's move on to G's because I see a G in the numerator and I see a G squared or G to the second power on the bottom. So G, how many G's do I have in the numerator? 1. How many G's do I have in the denominator? Technically I got 2 because remember what to the second power means? It means G times G. This means G times G, right? So I got 2 of them. It's just kind of they're packed in there. So how many can I cancel out from the top and bottom? 1. I could take this 1. I cancel this numerator G with one of those 2 G's. So you know how I show that? Here's a little algebra trick. Cancel out the 2. Cross out the 2 because you still have 1 left. Did that make sense? Okay. So now, am I done with variables? I can move on to numbers. I got 9 and 18. I can simplify that, right? 9 and 18, 9 goes in. 9 goes in once. 9 goes into 18. I'll put a 2 there. So now I have everything. I just got to catch everything as I multiply across. I'm going to multiply h times 2. How would I write that, h times 2? 2h. You want the coefficient, the number part first. And then I multiply 1 times g, which is just 1g. So if it's just 1, we don't put the 1. It's you bury it. You just write g. Okay? So it's 2h over g. Okay, last one. Okay. So this one's going to have some more of these exponents. X squared over 3z times 9z squared over 5x. Okay? So let's start with variables. Look across. What can we cancel? I can cancel x's, right? How many x's can I cancel out from the top and bottom? 1. So this one is gone. And one of these 2 goes away, so I'm just going to cross out the 2, show that. Do the same thing with the z's, right? I can cancel out this z. This z divides with one of those z's. So I'm still going to have that z left. Okay? All right. Can we do anything with the numbers?
Yes.
I got a 3 and a 9. I can divide out 3 here. So 3 divides with 3 and I get 1. And 3 divides with 9 and I get 3. So now I have everything I have canceled, or everything I could cancel. And I'm just going to multiply x times 3 times z. I'm going to multiply x times 3 times z. Put the number 3xz. So the rules are normally the number first, then the variables in alphabetical order. Okay? And on the bottom, 1 times 5, so just 5. And that's my answer. 3xz over 5. And there you go. So that's what we're going to practice over the weekend. Any questions? Does that seem okay? All right, I got to